Yeah, last class what we are doing now. So what are the physical properties we did? So C1 to C4 are gases, and C5 to C14 are liquids, and the density is increasing from top to bottom. So means number of carbons are increasing and increases, and boiling point and melting point are increasing with increasing the molecular weight or number of carbons are increasing. So what exactly happens? Surface area increases. When the surface area increases, what exactly happens? So more attractions, more van der Waals force of attractions. That's the reason melting and boiling points increases. Boiling points are inversely proportional to branching, and even number of carbon atoms are having the more melting points because the terminal ends are opposite direction and close packing structure is possible. And solubility, so the compounds, polar compounds are soluble in polar solvents, and non-polar compounds are soluble in non-polar solvents. Alkanes are non-polar. Obviously they are not soluble in water, they are soluble in like CCl4, benzene, etc. So alkanes are less denser than the water, so they are floating on the water. So generally fuels, gases and fuels are petrol, diesel, or of course all are alkanes only. So that's the reason they will float on the water, right? And chemical properties, we discussed that chlorination is it takes place. The chlorination is 1:2, right? 3.8:5. What is this? 1 degree, 2 degree, case of 3 degree for chlorine. If it is bromine, 1:, so 82:1600. So means more and more at 3 degree, then less somewhat 2 degree, then very less, because chlorine is, write it down, more reactive, more reactive, less selective. Chlorine is more reactive, less selective, whereas bromine less reactive, more selective. Less reactive, more selective. So chlorination and bromination. Bromination is also we can do like that. So if the tertiary carbon is there, for example, the compound is like this. If the bromination takes place, majority bromine will attack at 3 degree carbon, right? That one. Because 1600 times, here is somewhat less, 1:3.8:5 in case of chlorine, whereas in case of bromine 1:82:1600. Next, put the heading iodination. For example, pH3, pH2, pH3 plus I2, right? See, it's a reversible reaction, right? pH3, pH2, I plus HI. HI is a strong reducing agent, and this reaction is endothermic reaction. Endothermic, and that is strong reducing agent. Once again it is coming back and we will get the alkane. So write it down. It's a endothermic reaction, highly endothermic. This is highly endothermic reaction. Highly endothermic reaction. Generally exothermic reactions are more favorable. This is endothermic reaction, means we need to give the heat, as well as the HI is strong reducing agent. So backward reaction takes place. Strong reducing agent and backward reaction takes place. So actually this reaction generally won't take place, but we can do this in presence of oxidizing agents. So oxidizing agents, what they'll do, they'll oxidize the HI. So HiO3, in presence of HiO3 takes place. I2 plus H2O. 3I2, 3H2O. HNO3 also we can use. We can use the HNO3, NO2 plus H2O, I2. HGO also we can use now. Actually these products and all not needed. These are not needed actually. So why we are using HiO3, HNO3, HGO? So whatever the I is forming, right? So to prevent the backward reaction. To prevent backward reaction, so we will use these oxidizing agents. We have to use, write it down. So to avoid this oxidizing agents, we have one Finkelstein reaction, right? Finkelstein reaction. So it's a halogen exchange reaction. Halogen exchange reaction. It's a halogen exchange reaction. To prepare iodoalkanes, iodoalkanes from chloro and bromoalkanes, or Cl or bromine in terms of NaI, acetone, Ri, iodoalkanes plus NaCl is going out. RBr, NaI, Ri plus NaCl, NaBr. So these are the reactions which is coming in the, it's a named reaction. It's coming in the second year, of course, to prepare iodoalkanes. So directly we can prepare, but directly when we are preparing, we have to use that oxidase, right? So that we need to remove that HI. For that purpose, we are using oxidizing agents like HI, HiO3, HNO3, HGO, like that. So to avoid, so first we need to do chloroalkanes. From chloroalkanes, if we are adding the NaI, directly we are getting the iodoalkanes. Next now. So fluoroalkanes also we can prepare, but directly we can't prepare because fluorination is highly explosive in nature, fluorine. So that's the reason we'll use which reaction? Which reaction? Hello? Quartz reaction. Quartz reaction. So either chloro or bromoalkanes, RCl, RBl, Hg, AgF, or Hg2, F2 or Sb, F3 or CO, F2. So anything we can use, we'll get RF. Fluoroalkanes we will get now. Write it down. Next put the heading now, nitration. Nitration. For example, if you are taking the propane, CH3, CH2, CH3, propane in terms of HNO3 at 620 Kelvin, we will get different types nitration mixture of products we will get here. So we'll get 2 2 nitropropane plus we'll get 1 nitropropane plus nitroethane plus nitromethane. Like mixture of products we will get. Nitration case. Write it down. Next, sulfonation. Sulfonation. So order of reactivity, alkanes 3 degree hydrogen, then 2 degree hydrogen, then 1 degree hydrogen. So we are using So H2SO4, friends of SO3, fuming sulfuric acid we will use, or H2S2O7 also we can use. H2S2O7. So H2S2O7 we are called as what, Nana? Oleum. Oleum. So here is the hydrogen is there. Methyl ships. Methyl, SO3 H we will get. Write it. Oleum or anything. So 3 degree hydrogen. There is 1 degree hydrogen is there, but the reactivity of 3 degrees substituted by more and more. So SO3H we will get. Sulfonation. Next, combustion reaction. Combustion. Combustion, whenever the alkanes and combustion takes place, what exactly happens? We'll get CO2 and H2O and heat is released. Right? For example, CH4 plus 2O2 gives rise to CO2 plus H2O, get 2H2O plus heat. Write it down. C2H6 plus O2 gives rise to CO2 plus H2O plus heat. So we can balance the equation. Otherwise, balanced equation we can write like this, Nana. Cn H2n plus 2 plus 3n plus 1 by 2 O2 gives rise to NCO2 n plus 1 H2O plus heat. Write it down. This is the equation. It is what? How many oxygens are there? Obviously it is NCO2, right? NCO2, 2CO2, 3H2O. So 3n plus 1. 2 plus 1. 2. 6 plus 7 by 2. 7 by 2 O2. 7 by 2 O2 like that. We need to balance the equation. Any organic compound, any alkane. So next, Nana, catalytic oxidation. Catalytic oxidation. I told you combustion case, what exactly happens? More number of carbons, more combustion. So catalytic oxidation means controlled oxidation, means particularly, so we are using specific catalyst and specific conditions, we get desired product. For example, we will take methane with oxygen, generally 9:1 ratio, at 100 atmosphere pressure, 100 atm pressure, copper, so 470 Kelvin. Particularly we are maintaining all these, we will get CH3OH, we will get all alcohols. For example, one more reaction is there, total 4 reactions are there. Huh? If we take the methane plus O2, MO2O3, molybdenum or trioxide will get formaldehyde. Formaldehyde, write it down. For example, if you are using manganese acetate, manganese acetate we will get carboxylic acid. Generally higher alkanes we will get. No? Next, fourth reaction, 3-degree hydrogen. In NCERT they given same as it is, so we need to go with the NCERT flow. So 3-degree hydrogen only converting into alcohol. Write it down. These 4 reactions we need to remember, very important. Next, put the heading isomerization. What is isomerization? Isomerism takes place, means either chain isomerism or position isomerism. For example, if we can take 1, 2, 3, 4, 5, 6 hexane on heating with AlCl3 now. Anhydrous AlCl3 on heating. So what exactly happens? Isomers. What are the isomers? Compounds which are having the same molecular formula but different in their structure. Chain isomers are like that forming. So write it down. Isomerization. N-hexane this is. This is 2-methyl pentane. This is 3-methyl pentane. Methyl pentane, 3-methyl pentane. For example, AlCl3. So like this we can get isobutane, N-butane, isobutane. Next, aromatization. This is one of the important reaction, from alkanes to convert aromatic compounds means benzene ring, right? For example, if you can take 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Actually, N-hexane this, I am just writing like this. In presence of Cr2O3, right? Al2O3 plus Cr2O3. No. Or we can use V2O5 also. Or we can use MO2O3. MO2O3, any of 3 reagents along with Al2O3. So after directly we'll get here, first cyclization takes place, afterwards converting into benzene ring. 6-membered, right? If you are taking the 7, what exactly happens? We'll get toluene. We are taking the 8-membered ring. We'll get mixture of products now. CH2 ethyl benzene or glycine, ortho dimethyl benzene or para dimethyl benzene also possible. Write it down. Aromatization from, for example, propane is there. Propane on Wurtz reaction will get hexane. Hexane on Al2O3 plus Cr2O3 will get benzene. So benzene to prelugraphs, alkylation, acylation, nitration, anything we can do. Next, pyrolysis, cracking, or I could say pyrolysis, or we could say thermal decomposition. So this is cracking or pyrolysis or decomposition. So absence of oxygen, we are just heating, right? For example, in this case, when the pyrolysis takes place, lower alkenes and alkenes we will get. Lower alkanes and alkenes. When we are taking the higher number of alkanes, for example, it is what 1, 2, 3, 4, 5, 6, 7, 8, for example, an octane is there. Heating, absence of air, if air is there, combustion reaction takes place. Absence of air, what exactly happens? The product could be anything. Either it could be an hexane, 1, 2, 3, 4, 5, 6, 8, right? Plus ethene, plus hydrogen, like that. Or 1, 2, 3, 4, pentane, plus propane, anything. Any possibilities are there. Lower number of alkanes and alkenes. So generally the products doesn't matter here because we don't know which products are forming. Thermal decomposition, cracking. The word is name, we could say the cracking. Alright, crack antam kada. So reaction also crack. We don't know the products, which type of products are forming. Next, fractions of petroleum. So write it down. C1 to C4. Right? Gaseous hydrocarbons. The boiling point range up to, so as a fuel of liquefaction. So gaseous hydrocarbons, right? C5 to C7 petroleum ether. C5 to C7 petroleum ether. Petrol C7 to C9. C7 to C9 means what? Heptane to nonane. So there we are using the petrol. So petrol is a hydrocarbon. Next C9 to C10 benzene related. For dry cleaning, motor fuels we are using now. Kerosene oil C10 to C13. How many of you know kerosene? Kerosene, the kerosene, earlier days the stoves were there, right? Diesel C13 to C18. So diesel C13 to C18. Petroleum jellies, petroleum wax, so C18 to C30. Medicinal oil, motor oil, grease C15 to C18. Grease means the molecular weight is increasing, they'll become solids right now. I told you C1 to C4 are gases, and C5 to, of course, C14, both in between liquids like petrol, diesel, kerosene oil, they're present in between them. So if you are going the higher vaccines, wax, petroleum wax, gels like that, we will get it on. Write it down. Yeah, just what you need to do, you need to go line by line in the NCERT. So classification, so homogeneous, heterogeneous, right? Alkanes, nomenclature part, ethyl. So beautiful examples are there in the NCERT. Because NCERT, if you go with the Singage book or something else, we had n number of things, but NCERT is the standard book, so which we need to follow, right? Preparation of alkanes from alkenes, hydrogen, nickel, platinum and palladium, right? From alkyl halides, zinc and prions of HCl, and Urge reaction from carboxylic acids and coal-based electrolysis. But in coal, only some examples are there, but I already told you how we need to, right? Coal-based electrolysis, substitution reaction, halogenation, and Alcira, it is melting points. I told you, even number of alkanes, right? Even number of alkanes here, see, here is 101, ethane, 101, propane is odd number, right? It's 85. Where in case of butane is 134, but pentane is 114. For example, propane is 85. Propane is the odd number. Whereas in case of butane, 134. It's increased. Whereas in case of pentane, 143. But whereas in case of like that, so it's keep on changing if the branching and everything is coming. So just to, no need to by heart the values, we need to understand the number. So chlorination, I told you HiO3, HNO3, iodination is takes place. So chain initiation, chain propagation, right, and chain termination, combustion reaction, right. So highly exothermic, so 890 kilojoule per mole. Here is controlled oxidation, copper 523 ATM, so MO2O3, manganese acetate, and right, these 4 reactions are very important. Aromatization Cr2O3, V2O5 or MO2O3, 773 Kelvin. Reaction with steam raw, so I think I didn't explain this, so write it down. CH4 plus H2O, steam, you'll get CO plus 3H2. Just write this one more equation, right? This one. This is H2O run. Next, pyrolysis, C6, different compounds are coming. Pyrolysis of alkanes, aromatization, conformation, so Sahar's structure, Newman projection, I already explained this, eclipsed, staggered, right? Structure of double bonds. There is a torsional strain, dihedral angle, I already explained, right? Van der Waal expression, so obviously. Next, actually petroleum and octane, those things are there, I'm not explaining right now. Octane number and calorific value, those things actually not needed right now. So first, whatever the things are present in the NCERT, right? In NCERT, so just go through the NCERT. Next we'll do alkenes chapter. Alkenes I'll start tomorrow, okay? Alkenes, I'll explain tomorrow. Fresh topic. Meanwhile, what you need to do is go through the NCERT with line by line, okay? And any doubts or any reactions, so if you need, sir, I need more explanation in this particular reaction, please let me know, I'll do those reactions.